Next, we want to consider something called a complement rule or complementary events. So the complement of A is the event not A. We'll write that with a superscripted C above there. And then notice that the probability of an event plus the probability of its complement has to equal 1. So that means that if we brought the probability of a complement over here, that probability of A is 1 minus the probability of a complement. Or if we brought the P of A over as a negative, probability of A complement is 1 minus probability of A. So if you got complementary events, you know the probability of one, you can find the probability of the other. And sometimes it's easier to find the probability of the complement event and use that to find the probability of the actual event. So for example, if we look at B complement in example 1 in the previous problem here. So B is biology majors. There were 28 biology majors. So B complement is everyone who is not a biology major, which is going to be math or chemistry. So the probability of B complement, we can do 1 minus the probability of B. That's the complement rule. And we know what probability of a biology major is. It is 28 out of 78. So instead of adding up the other numbers, we could just do 1 minus 28 out of 78, which is 78 out of 78 minus 28 out of 78, which is 50 out of 78. So that's the probability someone's not a biology major. Here's another example. We've got some sample points here, E1, 2, 3, 4, 5, and 6. Here are the probabilities of each one of those sample points. And we want to know what's the probability of a complement. So everything that's outside the circle for A. So that is going to be that region there and that one. So there are 3 sample points there we could add up. So we could either add up the probabilities for E4, 5, and 6, or we could add up E1, 2, and 3 and subtract from 1. Let's check both ways. So probability of a complement is 1 minus the probability of A. So it is 1 minus, and then the probability of A will be, add the probability of the sample points E1, 2, and 3. So 0.2, 0.05, 0.3. So that's 0.55, 1 minus 0.55, 0.45. So that's one way to get it. Or that's going to be the same thing as adding up the sample points that are outside, which is 4, 5, 6. So 4 is 0.3 plus 5.1 and then 6.05. And that does still give us our 0.45. What about the probability of A complement intersect B? So A complement is the part that's outside A, and then we're going to intersect that with B. So here's B. So we want the part of A complement that overlaps with B, which is going to be this crescent moon right here. And that has 2 outcomes in it, E4 and E5. So this is going to be probability of E4 plus probability of E5. So 0.3 and 0.1 or 0.4. Now another way to look at this A complement intersect B, that is all the sample points that are in B and not A. So this probability of A complement intersect B is all the stuff that's in B, so it's going to be probability of B, and then minus the stuff that's in B but not in A. So, or we want the things that are in B but not A, so we're going to subtract out the part of A that overlaps with B. So A complement intersect B is the same as B minus A intersect B. So probability of B, that is 3, 4, and 5. So 0.3, 0.3, and 0.1. So this will be 0.3 plus 0.3 plus 0.1. And then subtract out the overlap. A intersect B is just a probability of 3, which is 0.3. So that's 0.7 minus 0.3, also 0.4. So that's another way to look at A complement intersect B.